Welcome to my science club, where curiosity turns into cool science magic.
Hello everyone, today's experiment is the mystery about the floating orange. It is an experiment about density. All you need is a whole orange, a peeled orange, and 2 jars filled with water. Now, what do you think will happen when I put the whole orange into the jar? Do you think it will sink or float? Let's find out. Wow, it floats. And now, what do you think will happen with the peeled orange? Do you think it will sink or float? Let's find out. Wow, it sunk. Now let's take a look at the science behind this experiment.
This is the brief on buoyancy and density. We're using a super simple kitchen experiment. You know, why a whole orange floats, but a peeled one just sinks, to instantly break down how density actually works in the real world. First, let's talk about the life jacket effect. An unpeeled orange floats because its rind traps all these tiny pockets of air, right? This trapped air makes the overall density of the orange less than the water it sits in. It's literally like the fruit is wearing a pool floaty. So what happens if we strip that floaty away? Second, we see a rapid density shift. See, peeling the orange completely removes that crucial air layer. Without its little life jacket, the dense, juicy fruit inside is actually heavier than the water it displaces, so it just sinks straight to the bottom. Finally, let's scale this whole concept up to massive metal ships. I mean, heavy steel ships float for the exact same reason as our unpeeled orange. Their hulls are absolutely full of air, which makes their overall density so much less than the ocean water around them. Ultimately, it's the overall density, not just the raw weight of the materials, that determines if something stays afloat, whether that's a piece of fruit or a massive ocean liner. So next time you watch something sink or float, remember, it's all about the air inside.